Hi, this is Tom Reardon, math teacher from Ohio, here to solve another SAT math problem with you. We suggest that you pause the video and copy the problem down, solve it at least one way, and resume when you're ready. Let's first look at an algebraic solution. So this is our function p of x. You'll notice that the zeros of p are at x equals -8 and x equals +12. And so the axis of symmetry should be halfway between those two. And that's also where I'll get the x-coordinate of the vertex. So I'm going to find the average of -8 and +12 by adding them up, dividing by 2, and that's going to be at x equals 2. So that's where this function reaches its maximum at x equals 2. However, the q function has a shift 4 units to the left. So I'm going to add -4 to that +2 and get x equals -2. Now, if that was unclear to you, the next one is a visual solution, which I think will help quite a bit. So let's go ahead and graph the p function using our graphing calculator. So I'll type in into y1 the opposite of the quantity, x plus 8, close parentheses, left parentheses, x minus 12. And I'll go ahead and graph this with my standard window. And my standard window goes, by the way, here. And the vertex is going to be somewhere above here. It's going to be opening downward, so the vertex is somewhere up here. But let's go ahead and graph the q function. So I'm going to go back to y equals, and in y of 2, I'm going to graph, instead of p at x plus 4, y1 at x plus 4. So to get the y variables, alpha trace is the place to get all the y variables, alpha trace. I want the first one, so I'll press 1 or enter. Left parentheses, x plus 4. Right parentheses. And so the one that I want is going to be graphed in red. So I'll go ahead and graph it. And you can see that it's been shifted 4 units to the left, blue to red, 4 units to the left. And now I can go ahead and find where it reaches its maximum. I don't need to see that, but I think I'll show that here. So I'm going to go ahead and change the window so that the y max goes up to maybe 150. That should be plenty. And maybe a y scale of 10 so it doesn't have too many tick marks on it. And let me go ahead and graph that. And so now you can see about where the maximum is, about what the x coordinate is. And remember, the calculator has a calculate menu. Second trace is the calculate menu. And I can find the maximum, number 4. So right now I'm on the blue function, so I need to press the up or down arrow to get on the red function. And it wants to know the left bound. So it looks to me like a left bound might be like maybe -5. So instead of moving the cursor, I just like to type in the x value, -5, and press enter. And it puts a little boundary line there. It's asking for the right bound, and I think 0 or 1 might be a good one. I think I'll just type in 1 for the right bound. And then it says a guess, and the guess could be anywhere number in between there. So you could guess 0, or you could just guess the last coordinate, last value, which was 1. So I'll just press enter. And you can see you're getting a maximum value of -1.9999, which for all practical purposes -2, because this is an algorithm. It's not doing it algebraically. And the y coordinate is 100, okay? But the one we want is x equals -2. So again, here are the screenshots of how we got there. And I want to point out that other videos are available at this website.